All right, so today we're going to be looking at section 8A.2. We're going to be using trig with right triangles, and today we're going to be looking at 6 trigonometric functions. And our learning target is just that I can find all 6 trigonometric functions of a given angle, given a diagram, or any information about that, all right? So first of all, let's just recall what we've discussed about this symbol right here. This is the Greek letter theta, so I just want to officially define that. This is the Greek letter theta, and what this does is this represents an angle measurement, or I should just say an angle. It represents an angle, and then oftentimes we find the measurement of that angle theta. Okay. So, again, based on what we've looked at, reviewed in the last lesson, when we have a trigonometric ratio, or sometimes we just call that a trig ratio, that is the ratio of the lengths of 2 sides of a right triangle with respect to one of its acute angles. So again, we don't do it in respect to the right angle, the 90-degree angle, but with respect to one of its acute angles. And again, we use the words opposite, adjacent, and hypotenuse to describe the sides of the triangle in these ratios. So hypotenuse is always across from our right angle. Opposite is the side opposite the acute angle we're looking at. Adjacent is the leg that touches the acute angle. Okay. And you have studied the sine, cosine, and tangent ratios. But today we are going to study 3 new ratios. Those are called the cosecant, the secant, and the cotangent. But as you learn, if you know the sine, cosine, and tangent, the cosecant, secant, and cotangent will be a piece of cake. So remember that sine is abbreviated just S-I-N, and that's said sine, not sin. And when we take the sine of an angle theta, what 2 things do we divide? We take what divided by what? Opposite over hypotenuse. Excellent. Okay. What about the cosine of theta? Adjacent over the hypotenuse. And the tangent of theta? Opposite over adjacent. And we know that these are the abbreviations. Again, cosine is COS, tangent is TAN, okay? Now, cosecant can't be COS. Do you see that that would be the same as the cosine? So cosecant is abbreviated CSC. And the cosecant ratio is the hypotenuse over the opposite. Secant is abbreviated SEC, and that is the hypotenuse over the adjacent. Cotangent is abbreviated COT and is the adjacent over the opposite. Now, even though these are 3 new ratios, What do you notice about the ratios in the first column and the ratios in the second column? Yes, what is that called when they're flipped? Reciprocals, very nice, okay? So they are reciprocals. And oftentimes we write reciprocals as in general as 1 over something, even though you think about switching the numerator and denominator. The cosecant of theta is 1 over the sine of theta. And again, that symbol, you guys, means reciprocal. The secant of theta is the reciprocal of the cosine. And the cotangent of theta is the reciprocal of the tangent, okay? So again, yes, if it's just one number, you can put 1 over that, but I think it's important that we just remind you guys that that's the notation for a reciprocal. 1 over whatever is representative of the reciprocal. So in example 1, it asks us to evaluate the 6 trigonometric functions of the angle theta. And when we evaluate the 6 trigonometric functions of the angle theta, we are going to list the sine of theta, the cosine of theta, the tangent of theta, as well as the cosecant of theta, the secant of theta, and the cotangent of theta. Which one of those are we able to find right away without doing any written work? In relation to theta, we have 24, which is the adjacent, and 7, which is the opposite in relation to the angle marked theta. So if we think about our 3 classic trig functions, which of the 3 classic trig functions could we find right away? The tangent, and that would be 7 out of 24. Therefore, which of our new trig functions could we find right away? The cotangent. It would be the reciprocal, which we'd write as 24 over 7. But we don't know the hypotenuse. Is there a way that we could find the hypotenuse? Yeah, of course. We can use our Pythagorean theorem. A squared, oh, and so we're looking for our hypotenuse, which is always like our C. So A squared plus B squared equals C squared. And we can use the Pythagorean theorem to find our missing side length. So these are both on the same side, so I can take 7 squared, which is 49, plus 24 squared, which is 576, to get that 625 equals C squared. Then I could take the square root, and normally we do plus or minus, but because we're talking about side lengths, we'll just say that C is 25. Okay. So now that we know that C is 25, we can find the other trig functions. We know the sine of theta is our opposite over hypotenuse, which would be 7 over 25. And that means that our cosecant would be 25 over 7. Our cosine is adjacent over hypotenuse, so that would be 24 over 25. That means our secant would be 25 over 24. Okay. And those are the 6 trig functions of our angle theta. That's it, okay? So why don't you guys try this you try question. Notice our angle theta is in a different spot here, So make sure that we're looking at this particular angle theta that is marked in this picture and evaluate appropriately and see what we can do to find those 6 trigonometric functions. Okay, a couple things about notation in our answers. Well, first let's start. One thing is that when you have this angle theta that's marked, you have to look at the sides in relation to that angle. This 15 is across from that angle theta, which means that is the opposite. This is the adjacent, the 17 is the hypotenuse. So first, make sure that we're labeling those correctly. Secondly, when we have this here, make sure that our hypotenuse is always the c squared. In example 1, we were looking for the hypotenuse, so we could take the 2 sides and have them on the same side of the equation to equal c squared. But here we have to do it a little bit differently. And we're going to want to find that a or b or x or whatever equals 8. Okay? So then I want to talk to you guys about notation. Sometimes I see this. That's not good. Okay? This is saying the sine of 15/17. We want to make sure that we are saying the sine of theta equals. Another bad thing I sometimes see is just cosine equals. You have to take the cosine of an angle. So it's the cosine of theta equals. So just make sure that we have these thetas in your, we don't just want to take the sine of something that doesn't exist, okay? So that's what our answer looks like for the U right? All right, so the next type of questions. This time they don't have a triangle drawn. It says if theta is an acute angle of a right triangle and the cosine of theta is 3/8, what is the value of cosecant theta? If we have time, we'll find them all because that's what you'll be asked to do in the homework and on a quiz situation. We kind of ran out of room on the notes. So here are the steps I'm going to suggest. The first thing is that it helped us in the other problems when we had a picture. So what you're going to do is make sense of the ratio and draw a picture. Okay. The second thing we're going to do is to find the missing side length. And we've been doing that by using the Pythagorean theorem. Lastly, we're going to evaluate. And in the other problems that we dealt with, they came out pretty. In example 2, we're going to practice rationalizing when necessary. So to rationalize means that we don't want any radicals in our denominator. So we'll review how to do that. So let's try that with example 2. It says if theta is an acute angle of a right triangle and cosine theta is 3/8, it's saying what's the value of cosecant theta? All right, so let's first make sense of the ratio and draw a picture. So we know that we have a right triangle. And we know that theta is one of the acute angles. So I'm just going to draw theta as one of the acute angles. Now, cosine is adjacent over hypotenuse. And that means I'm going to need to label this triangle in relation to theta. I want the adjacent to be 3. So this is the opposite. This is the adjacent is 3. And the hypotenuse is 8. So that's the first thing. Now this problem looks very much like the other problems that we've dealt with. We can then find the missing side length. 3 squared and 8 is our hypotenuse. So you could call it b squared or x squared or whatever you want. But the 8 squared has to be the c squared value. So I have 9 plus b squared equals 64. B squared equals 55. I'll take the square root of 55, plus or minus, but again, it's a side length, so I would just do square root of 55. Now, does 55 have any perfect squares that divide into it? No, so we'll just keep that as the square root of 55. Well, now it's asking us to evaluate. This is asking me to find the value of cosecant theta. Okay. Now this is one of our new trig functions. So what we might think to ourselves is, what is the reciprocal of? What was cosecant the reciprocal of? Sine. And we knew that sine was opposite over hypotenuse. So that means that cosecant is hypotenuse over opposite. So let's put those values in. Our hypotenuse in this case is 8. And our opposite is what we found is that square root of 55. This is not the way that we'll be leaving our answers. We want to rationalize this. Do you remember what we have to multiply by to rationalize? We'd have to multiply by root 55 over root 55. That's a form of 1. That's legal. Eight times root 55 is 8 root 55. And what happens when I take root 55 times root 55? Just 55. So we multiply the radical by itself so that we're squaring it and the radicals cancel and we're left with something like this. Okay. Let's say that I was asked for the tangent of theta. What would the tangent of theta be in this question? We would take the opposite, which is root 55, over the adjacent, which is 3. We don't have a radical in the denominator, so that would be just fine. Okay. What if I had the cotangent of theta, however? The cotangent of theta is the reciprocal of the tangent, or is the adjacent over the opposite. Could I leave my answer like that for cotangent? No. I would need to rationalize this and multiply by root 55 over root 55. And I would get that the cotangent of theta equals 3 root 55 over 55. Okay. And you could find the other values as well very easily. The sine is the opposite over hypotenuse, root 55 over 8. The secant is the hypotenuse over adjacent, 8 over 3. I just want to review that idea of rationalizing with you, okay? So now that we've done example 2, why don't you guys try this try question. There's less work for you to do in this one. It says if theta is an acute angle of a right triangle and the sine of theta is 6/10, what is the value of cosine of theta? Okay, so see if we can take a second and do those questions. Okay, so this was a very popular answer, 8 over 10, but what did I have to tell lots of you guys to do? Reduce. We always reduce. We always want to express our ratios in simplified form, which means that if you can reduce the fraction, you reduce it. And if you can rationalize, you rationalize it so that those numerical values are as simple as possible. Several of you guys also found the other values, which was adorable. Okay, so if we wanted to have the tangent ended up being 3 over 4 if you reduced. The cosecant was 5 over 3. The secant was 5 over 4. And the cotangent was 4 over 3. So that's perfect. Just make sure you reduce those. Okay. Now I want to review with you guys, and this is more kind of a precursor to the next part of the unit, but we really want to make sure that you have a strong idea about this. I want us to review the special right triangles that you guys learned last year in geometry. One of the special right triangles was a 45, 45, 90 triangle. And oftentimes what we did is we learned these as like, I don't know if you used A or B, but like as A, and then do you remember what across from the hypotenuse was? A root 2. Vaguely remember that? No? Okay. That's why we're reviewing it, okay? In general, however, what we're going to think about is we're going to be using the ratios of these sides. So aren't the A's pretty much all going to cancel if we divide them by each other? So for right now, I just want us to think about this side as root 2, this side as 1, and this side as 1. Okay. Because again, we could put any values there. It could be 3, 3, 3 root 2, whatever, but that's pretty much what that is, okay? Then there was the 30, 60, 90 triangle. And the 30, 60, 90 triangle, maybe you guys learned that across from the 30, we labeled that B. Do you remember what was across from the 60? B root 3. And across from the 90 was 2B. Well, again, if we're dealing with ratios, those B's are going to cancel. So I'm going to call this 1, this just root 3, and this just 2. Okay. And that way we just have a little less simplifying to do. So in what's coming up in the rest of this unit, 30 degrees, 45 degrees, and 60 degrees are angles that are frequently used in trigonometry. We can use these special angles to find unknown side lengths in these special right triangles. We're going to fill in this table. Eventually, these are all going to be memorized, not before the quiz this week, but that's what we're going to be working towards in Unit 8B. So let's just start with 30 degrees. I'm going to mark this 30 degrees. And Let's write what the sine of 30 degrees always is going to be. The sine is opposite over hypotenuse. So the sine of 30 degrees is always 1/2. What do you think the cosine of 30 degrees would always be? √3/2. Now let's think about the tangent of 30 degrees. Tangent is opposite over adjacent. The issue is that our adjacent is irrational. So just down here, I'm going to put a little 1/√3. Wouldn't we need to rationalize that? We would multiply by √3/√3, and that's going to become √3 over just plain 3. Okay. Now, based on what we learned today, we can find these other measurements also. If the sine was 1/2, what would the cosecant be? 2. The cosine of 30 degrees was √3/2. So the secant of theta is going to be 2/√3. But again, we have that radical in the denominator. We'll want to rationalize and multiply √3 in the numerator and in the denominator and get 2√3/3. Now for cotangent, we could take the reciprocal of the √3/3, but then wouldn't we have to rationalize this again and then simplify? Why don't we take the reciprocal of the original ratio? Our original ratio was 1/√3. What would the reciprocal of that be? Just √3. And those are some of the ratios, and what we're going to learn about is called our unit circle, which we'll look at in our next unit. Let's also find the ratios for 45 degrees. Let's go back to our 45, 45, 90 triangle and try to find these ratios. The sine of 45 is opposite over hypotenuse. So that's 1/√2. Uh-oh, we need to rationalize. So we'll multiply by √2/√2. That gives me √2/2. Now let's try the cosine of 45. The cosine of 45 is the adjacent over hypotenuse. Again, 1/√2. Again, we'll rationalize. That's going to be √2 over just plain 2. The tangent is the opposite over adjacent. 1/1, and 1/1 just becomes 1. Now let's find the reciprocal values. Instead of taking the reciprocal of √2/2, let's think about it as the original reciprocal, or as hypotenuse over opposite, and that's just plain √2. Hypotenuse over adjacent is just plain √2. And adjacent over opposite, 1/1, is again 1. All right. Lastly, let's find the ratios for 60 degrees. So for 60 degrees, we look at opposite of 60, which is √3, over the hypotenuse, which is 2. That works out. We look at the adjacent of 60, which is 1, over the hypotenuse, which is 2, so 1/2. We then look at the opposite of 60 over the adjacent, so √3/1 is just plain √3. Now we have the reciprocals. For cosecant, we would take hypotenuse over opposite, but we have a problem. We would need to rationalize. Hopefully you guys see that this is just going to be 2 root 3 over 3. I can take the reciprocal of 1/2 easily. That just becomes 2. And the reciprocal of root 3 would be 1 over root 3, which we would need to rationalize, and that becomes root 3 over 3. So again, what we're doing today is just giving you guys a taste of these ratios. And there are some problems in the homework where we're going to ask you, instead of using your calculator and the trig functions, to use these exact values to help you find the values in special triangles involving 30 degrees, 60 degrees, or 45 degrees. So example 3 says to find the value of x and y in the right triangle shown. Which angle do you guys want to focus on, 30 or 60? It doesn't matter to me. All right, I get more 30. Sorry, Caitlin. All right, so we're going to focus on the 30-degree angle. And let's start with finding x. Now, just like we did the other day, let's find a trig ratio that we can set up to help us find x. In relation to 30, x is the opposite, and we know 8, which is the adjacent. What trig function could we use? Tangent. So what we'll do is we'll say the tangent of 30 degrees equals our opposite, which is 8, over our over our adjacent, which is, I'm going to start over. Our opposite, which is x, and our adjacent, which is 8. Okay, now, the other day, what we did is we used our calculator. What I want you guys to try to do in the homework is to use the table instead. What does our table tell us that the tangent of 30 degrees is equal to? It says that the tangent of 30 degrees is root 3 over 3. So I'm going to replace the tangent of 30 degrees with root 3 over 3. And this way, instead of a decimal answer, we can get an exact answer. One way that you can solve something like this, there are a couple ways you could do it. One way is to cross multiply. And for you to say that 3 times x is equal to root 3 times 8, which is 8 root 3. So because these are ratios, we often end up with proportions that we can cross multiply. What would we do to solve for x? Divide by 3. So I have that x is 8 root 3 over 3. Let's think about another one. Let's look at y. Y is the hypotenuse, 8 is the adjacent. What trig ratio deals with hypotenuse and adjacent? Cosine. And usually we kind of revert to the classic trig functions, which is okay at this point. So we're going to say that the cosine of 30 is equal to 8 over y. Now let's use our table. What does our table tell us that the cosine of 30 degrees is? Oh, oops. Root 3 over 2. So we're going to replace the cosine of 30 with root 3 over 2. And then that equals 8 over y. Now let's cross multiply. I have root 3 times y equals 8 times 2, which is 16. To isolate y, I would need to divide by root 3, and I get 16 over root 3. But what will I want to do to my answer? Rationalize. So I would multiply by root 3 over root 3, and I find that y is 16 root 3 over 3. And that makes sense if we think about the relationship in 30, 60, 90 triangles, because the hypotenuse should be twice as long as the short leg. Real quick, see if you can do this U-try question and use the 45-degree angle to help us out here. So what I had here is that the cosine of 45 is the adjacent x over the hypotenuse 6. In the table, I find that the cosine of 45 is root 2 over 2, and then I can cross multiply. Sound good? Okay. You're going to use those in numbers 17 through 19 in the homework. It says use the table in the notes to help. You can set that up just that way, okay?